Hello dear students, today we will learn exception handling. It's a very unique feature of Java which gives us support to deal with unwanted event which may occur in the runtime or during the execution and try to hamper the normal flow of execution. So what can be those problems? To understand that, let us start with a very easy equation, and that equation is x divided by x minus 5, where x is a given integer. So how to write a Java code which will gives you the result of that? So that is our corresponding Java code, where we can pass any integer value to that x and we will get the output of x divided by x minus 5. So what if we pass the 10 to x? Well, we will get 2. What if we will pass 1? 0.25, right? No, we will get 0. Why? Remember, x is integer. So here 1 divided by 4 will give you 0.25. Now as this is an integer value, it will totally ignore that 0.25 and give you only 0. Now what if we pass the value of x is 5? Well, mathematically we cannot divide anything by 0 and we will get undefined. So what happened to our code? Whether it gives you an error? Well, is it? So is there anything wrong in the equation? Because if there is anything wrong, it will give you error. So as far as our equation is concerned, there is nothing wrong in that equation. So is there anything wrong in the code? No, there is nothing wrong in the code either. Because if you look at the equation or the code, in both cases, it will give you the proper output. Only in one case, where the value of x is 5, the system fails to give you any answer. So that is an exceptional case. That means the value of x is 5 is that exceptional case for which system will not able to give you any proper output. But apart from 5, for any given integer, system will properly gives you the answer. And that's why we call it an exception, because it is that unwanted or an exceptional case. So what is an exception actually? So basically it is an unwanted event or exceptional event which occurs during the execution and hampers the normal flow of execution. And there is a huge difference between an error and an exception. So what is that major difference? Well, an error is more fatal and it is irrecoverable. That means you cannot recover from the error. So you have to stop the normal flow of execution and correct those errors. Whereas in case of exception, we can recover from the exception. Most of the time that exception can be fatal or cannot be fatal. And if the exception is not so fatal, we can handle that exception during the execution time. So that exception are basically two types. One is checked exception, another is unchecked exception. Now in case of checked exception, we cannot able to check that exception in the compile time, but we can handle it in the runtime or check it in the runtime. Now why in the runtime? So let's get back to our previous code. Now here in that particular code, what is the job of the compiler? So the job of the compiler is to ensure whether the code is properly written. Now what happened to this 5 or this x minus 5 here? Well, compiler is not going to assign the memory for x. So if compiler won't assign any memory to x, compiler won't be able to calculate this value as well. All the compiler or the Java C will only take care about one thing, that whether this entire code is properly written or not. Now if Java C satisfies with the code, it will create the bytecode. Now at the time of execution or runtime, when Java deals with that bytecode, Java at this line, Java first assign X to in memory and assign value 5 to that memory. In the next instruction, Java will collect that value of X from the memory and put here and then do a mathematical operation, and that operation is 5 minus 5, which is 0, and then 5 divided by 0, and at that point Java realizes that there is an exception. So obviously it is not possible to check that exception in the compilation time. So this is the case of unchecked exception. Whereas on the other hand, checked exception can occur unchecked at the time of compilation. Now all the exception is throwable. That means we can throw that exception. So basically exception means whenever there is such unwanted event happen, system will create an object of that exception and throw that object. So as we can throw that object, we call that object as throwable, and all the unchecked exception are basically the subclass of runtime exception class. Whereas all other exceptions as well as the error are considered as unchecked, as checked. So apart from the runtime exception, all other exceptions are basically checked exception. So let us look at that hierarchy. So we already heard about the Java Lang package. So all those things are there in the Java Lang package, and remember the superclass is the object. Obviously it will be because we are dealing with object-oriented programming. Now this exception and error are only throwable. That means object doesn't mean that all the objects are throwable, but exception and errors are throwable object. Now this throwable is basically the subclass of that object, and error and exceptions are the subclass of throwable. So there are a lot of others errors and exception also, but we will focus on few of them. Now as far as these exceptions are concerned, this exception have several subclasses like runtime exception and other these exceptions. So apart from runtime exceptions, all other exceptions as well as the errors are checked. That means we can check it in the compilation time. Whereas on the other hand, runtime exceptions are unchecked. That means we deals with that exception in the runtime instead of compilation time. So runtime exception have several more subclasses like this: arithmetic exception, null pointer exception, array index out of bounds exception, and so on. And these exceptions have furthermore subclasses. So this is the overall hierarchy of the exception or error, throwable, etc. So now how to handle that exception? The very quick answer is try catch block. So what is the try and catch block? Well, as of now we can see that there are some instruction which may leads to that exception. Means, well, just like anything divisible by 0. So let us consider something which is divisible by 0, like 5 divided by 0. So if we try to write that instruction, there is a chance of exception. So we put those instructions within the try block. That means the instructions which may lead an exception. Now whenever there is an exception, system will create an object of that exception class and throw it. So if that object of that exception thrown by the system is able to catch by someone, we call it exception is handled. If not, then we are unable to handle that exception and the normal flow of execution will stop. So the catch block is basically for there. So it's like the fielders in the field. So if there is an edge and the catch is there in the slip, and if there is a player in the slip, he will able to catch that exception. If there is no fielder in the slip, the ball goes for the boundary. So basically, the purpose of the try catch block is to handle the exception. And how it will work? So we will put all those instructions where we think there can be a chance of exception in the try block, and if the exception occurs, then system will create an object of that exception and system will throw that object, and catch block eventually catch that object and handle the exception and maintain the normal flow of execution. So now understand this whole scenario with a piece of code. So let us start with a very tiny code where we have a for loop and we initialize x as 1, and there is an I which, or the range of the I is from -1 to 1, and in each iteration we will try to divide the x with the value of I. So at the very beginning, or we can say at the first iteration, the value will be 1 and divided by -1, which is 1, and then the I gets incremented. So now the -1 will incremented to 0, and in the next iteration the value will be 1 by 0, and that is a case of exception. So what happens? So whenever we have that exception, system will throw an object of that exception, and that exception is arithmetic exception, and no one is there to catch that object. So there is a problem in the normal execution. Why the problem? Because if there is no problem, then we will also able to get the value 1, which will occur in the next iteration. So after getting -1, system will stops working properly. So how this type of exception or this type of scenario can be handled with the use of try catch block? Well, so let us bring the try block. Now, as we already know that we put only those instructions in the try block where there can be an exception. So this is that instruction where there can be an exception. So we put that instruction within the try block. And now we bring a catch block which is able to catch an object of arithmetic exception. So what actually happens here? So whenever there is an exception which is for I equal to 0, system will throw an arithmetic exceptions object. So an object of arithmetic exception, and that object is now that catch block is now able to catch that object and will able to handle it. How? Just like that. So whenever we have an exception in that line or line number 7, system will catch that exception in this catch block, and here we are having an information that is java.lang.arithmetic exception, and it calls by divisible by 0, just like here. But after this exception, or after the catch is handled that exception, system again go back to its normal execution and gives you 1. So this is the usefulness of try and catch block. Well, in addition to that, I just would like to tell you one thing, that this is basically a reference variable, or OB is basically a reference object of arithmetic exception class. And that's why whenever there is an arithmetic exception occurs, we can pass that object through this catch. So basically catch block will take an object of exception as a parameter.